Good afternoon, everyone, and thanks for joining me this afternoon. My name's Peter Hunnaball. I've been with Flackwood since 1972, so you can guess it's quite a long time. I've been laboratory manager, run major projects, and I'm technical manager in the technical estimating team. So the purpose of this presentation is to outline the principles of ATEX and what we do in Colchester to make products for that. ATEX fans now fully replaces anything that might previously been called hazardous area fans or flame-proof fans that were really manufactured without a defined standard. So if we go on to the next slide. So really to try and give our customers, our team members, a better understanding of what it means for woods air movement. So what is ATEX? Why do we need ATEX? What does ATEX mean to the employer and the end user? That's an important thing at this presentation. The infamous ATEX form, which we request that people fill in, a bit of an understanding about what that means in terms of zones, categories, gas groups, temperature classes. What does that mean when we're trying to supply a product for it? And what does it mean to us as a manufacturer? What are our responsibilities? Just a little bit about the product and what the special features. So what is ATEX? This comes from the French atmosphere explosible. I hope that's not too terrible explanation. France, I have to give a lot of credit to for driving the ATEX legislation. They had a particularly nasty run of explosions and fatalities in the 1960s and 1970s, and they were very much at the centre of pulling different countries together, different experts together to put together a standard and a code for working with hazardous environments. There are over 90 ATEX related standards that relate to products and applications and installations. So you can see it's a complicated field. The background of ATEX is important. So what we call ATEX 153 is the ATEX Worker Protection Directive. This is what drives it all. The object of this is to give everybody who works within that common EU area an environment to work in which is safe if they have any hazardous facilities or atmospheres or anything within it. So that means that where they work has got to be risk assessed. That's the starting place of what goes on with ATEX, that the work area is risk assessed. So once that risk has been looked at, we then have another driver, which is ATEX 114, which is the Equipment Directive. So that means that ATEX 114 means that we manufacture equipment that will meet the risk requirements of ATEX 153. And so that's an important thing behind that. Just a reminder of that. So it's all about conditions and safety of workers, common ground in all different countries. In the UK, and this is just UK, but in every country in Europe, there'll be the equivalence of this, which is regulations that deal with dangerous substances. And so that puts in a duty on the employers to eliminate or control the risks. So that's risk assessment. That all comes under the ATEX 153. And there are a number of safety-driven documents that employers must comply with. Where you've got hazardous substances, then they have to be recognised. There'll be data sheets that will come with that, which will help the risk assessment. Why do we need ATEX? Well, sources of heat exist all around us. Let's take some very simple ones. So this is our computer and phone chargers, all right? The temperatures are not tremendously high, and we're advised to unplug our equipment at night, aren't we? And this is why the things do occasionally catch fire. Of course, if you were having that equipment in a hazardous area, you would have ATEX rated equipment, but it just goes to show that the simplest things can have a significant influence. Something like a pump, it's a lot easier to understand, I guess. There is the way that you drive a pump is with a belt, and the belt relies on friction. And so that friction is simply heat. And so it's very easy to have an environment where you have heat generation. Further complicated with things like belt drives by the generation of static electricity. So again, it would be specially EX rated equipment that you do to make sure that you didn't produce a hazardous in that area. One of the oldest ones, which fortunately I don't think anywhere in Europe can happen now, apologies for the quality of the photograph, is where we have a petrol pump, and you used to be able to put your pump handle into the tank, click a little switch and walk away, leaving it to fill up. You maybe then would go to your inside the car, move some things around, generate static electricity on your clothes, quite innocently come back. As you pull the pump out of the car, you then touch the car, spark, and that could be the consequences of that. So I think even in America now that is banned. So, the mechanisms of explosion with a gas, there are three important things that occur. We need to have oxygen, a heat source, and an explosive gas. If you've got those three things, then you've got the potential to have an explosion. If you take any one away, then that risk is gone. With dust, a little bit more complicated in that we have got to have a dispersed gas that is a fuel in effect, one that can combust, the ignition source, oxygen, and normally in confinement is where the problem would be. So it's a picture of what might happen. And this is the reality of what happens when it goes wrong. So the France featuring there, that's a fertilizer factory where ammonia nitrate was stored. The explosion could be heard 50 miles away. It made a 7 metre by 40 metre wide crater. That one is a sugar refinery in America. So, you know, we talk about big numbers of people who are killed, but when you see the devastation, then it's no surprise that there's such a high fatality rate. It's an oil storage area in Buncefield in the UK. Amazingly, nobody was killed, but they think that one of the reasons was put forward was that there was a lorry tanker spotted a leak and went to switch off the pump in his truck, but that switch wasn't ATEX rated. So there was a spark with the fumes and that went away. And then one of the more recent ones, another 15 dead in another fertilizer factory. Fertilizer, unfortunately, is quite often the base of different explosive environments. So what the next thing is a video that I've taken off the internet kindly. Unfortunately, I couldn't resolve where the source was. What they have there is a container that's full of sawdust chippings. It's just ordinary sawdust. His tank there contains ordinary compressed air. And he's got a valve there that's a time valve so he can walk away from it once he's switched it on. So I say that's just full of sawdust. So what it does is to put just an ordinary road flare in there. You can see, all right, quite happily sits there with no risk. So it's going to switch on the time valve with the compressed air. So after a time, that will then blast compressed air through the dust, making it into a cloud. And that is quite devastating. I think we can all see the power within that. So I think, well, is that really relevant? What does that mean? Well, unfortunately, it is, because in Bosley Mill in Cheshire in 2015, a wood processing plant. There were 4 people killed. And the understatement was there were dust issues at site. In other words, the place just wasn't cleaned. It wasn't made safe for the people inside. But it's totally decimated that factory. And while the owner was given a suspended prison sentence, the company fined close to €100,000. That's no compensation for the 4 people who lost their lives. So we like to think we're in a safe and developed environment, but the reality is that dust is the risks are everywhere.
There's actually,
so, in other words, what we rely on, what ATEX relies on, is that the owners of plant do their risk assessment. So that means not just a one-off. Every time there's a change in any process or materials or machinery, if you've got any sort of hazardous environment, you have to enter this loop of continuous safety review. Only by doing that can you really understand how to fill in the form for any equipment you've got to install in there, but also how the safety of the workers can be improved. Let's have a look at the relationship between the 2 directives. So we've got zones that will appear once that risk analysis is done. And basically this zone means that you have a continual risk. And if you're going to apply equipment in there, it'll be category 1. We do not supply anything into what is a permanently explosive atmosphere. Zone 1, zone 2.1, we've noticed the 2 note, so dust is now separated. Any dust designation begins with a 2. Okay, so zone 1 has category 2 equipment in it. And this would normally be for anything where there's a risk between 10 and 1,000 hours a year. So something where there's a reasonable risk. You would like everybody really to be working in zone 2 or 2.2. Category 3 equipment, this is where the risk is very, very occasional and maybe less than 10 hours a year. So it genuinely would be an accidental risk. It doesn't help people's understanding of ATEX when there's a difference within the zone and the equipment categories. And we quite commonly see that confusion. Because this is what we ask people to fill out. We ask people to put in the zones that their equipment is, inside and outside the casing, but we only take any notice of what's inside because we don't reduce the capability of our product outside the casing. We need to know the temperature classes, the maximum allowable surface temperatures, if there's any peculiar mixture of dust or gases. Those are all the things that help us to understand the equipment we're going to give. We need to know if it's going to be inverter driven, which is very common now. If there's any exceptional ambient conditions, all of these things make sure that we do the correct fan selection. This is what we don't want to see. This means nothing to us. Because what is it? Is it zone 1 or is it zone 2.1? So we do need people to do their homework, if you like. And so you can see that what we do, we very conveniently knock out anything which we won't do, but just try and give some guidance on what the form should be filled in with. So what does that really mean? This is probably the most commonly cited one because it's very rare that you'd get anything where you get the combinations. Within the tanks, clearly you have a permanent risk. So no equipment would be required there. Where you've got the occasional but regular leakage and seepage, so around the pump where it goes into the tank, where you're filling there if there's any air paths around it. But once you get to a certain distance away, the dilution becomes such that's very, very low risk. And so that way we start to group our gas things like this. So continually present, 10 to 1,000 hours a year, maybe a little bit more than that in reality, but unlikely to occur in normal use. So that's a useful picture to have. And then with dust, we get, again, the same thing, but beginning with a 2 to demonstrate that it's dust. One of the most confusing elements of ATEX and understanding the risk with ATEX is for the risk of combustion from the gases. Group 2C gases has the highest risk in terms of the ease of ignition. Okay, but there's very limited amount of gases that are covered within 2C. If you have a 2C product, that then automatically will cover 2B and 2A. That's often why people will specify 2C, but it then becomes a more special and expensive product and more complicated to make. The reverse of that, if you have a 2A product, it cannot cover 2B and cannot cover 2C. So it's important that the risk is understood. One of the things when you're looking at gases is to, when someone's doing a design principle for any gas installation, is to understand what we call the lower explosive limit and the upper explosive limit. These are dilutions by volume in air. Okay, so the risk with, let's look at hydrogen, as one we often see, is between 45 and 75% concentration. So that's the risk range, if you like. So if we look at hydrogen, if you're going to have a safe design for that, quite commonly that would be designed for a 1% dilution. So that's 25% of the lower explosive limit, a factor of safety of 4. And that's a very common historic design criteria. But that's not the only thing you have to know about. If the gas that you deal with is a heavy gas, there's no good trying to extract that at high level. You may need to extract that at low level. Some of the suppression gases, for example, you need to know if the density means that that gas is going to sit down at low level, because you might well be ventilating and achieving nothing. So the gas groups, we can see this is where, remember that the lowest risk of ignition and the highest risk of ignition. And you can see acetylene is the other one that sits in the 2C gases. So hydrogen appears there. Historically, hydrogen appeared in battery rooms with the old style lead zinc batteries, because when you charged the batteries, there was gas that came off. And so it's very common to see ATEX fans that were specified for battery rooms. But you can see that a 2B coverage, which is what our standard product is, will cover a huge range of products. Each of these products should have a product safety sheet available, or within the ISO standards, you can look at what gas group and temperature class any particular gas is. And so by looking at that, knowing what your process is, you can specify the right product. One that we've seen recently is, and we believe as to try and reduce costs, is 2B plus hydrogen. Now, the way that we build a fan is that every component in that product has to meet the requirement for the gas group and temperatures. And we haven't seen any major motor suppliers that will supply a motor for this. If we ask for it, it will come as a 2C motor. There will be some things, terminal boxes, etc., where that might apply. So just looking where we have, so these are the designations now that we have for the gases, goes 2A, 2B, 2C, but for the fibres and dusts, that's a little bit different now. So, but again, group 3C will cover B and A. So this is the lowest risk, this is the highest risk. And basically that is with conductive dust. So if you think about it, if you've got any metal filings, if you've got carbon, anything that will allow an electrical signal to be transmitted inside the motor along the shaft through the seals, etc. So that's the way that is. So very important. So you'd have, this would be, by example, cotton. You'd have cotton there. You'd have things like sugar, flour, paper, wood in the non-conductive ones. But things, as I said, metal dust, aluminium, zinc, carbon would all fall into that category. So the people need to understand how the thing is going to be used. So classes, these are well defined, and the standard product that we have is a group is T4. So that means the maximum surface temperature is 135 degrees. Okay, so that's automatically better than T3, T2 and T1, but won't cover T5 and T6. These require a special motor quotation, because basically what happens, the way you reduce the surface temperature on the motor is to derate the motor, as the winding will cool down. So this might be 10 kilowatts, the same motor for T6 might be 6 or 7 kilowatts. Okay, again, listed in ease of ignition. So a T6 motor would cover everything. A T1 motor would only cover T1. So obviously it's going to be higher than the T2, T3. But this is probably the most common classification for motors. So if we start to now add the temperature class to the gas groups, we can see that our standard T4 product covers almost everything. So very rarely that you really need to have T5 or T6. And always ask that question, does it really need to be there? So our standard fans, which are for gas, is T4, 2B, T4. So all of that envelope is covered by the standard product. So this is what you see in terms of a label on an ATEX fan. There are two groups of hazardous product. One is for underground mines, which we won't do because the liability is just too high. So product categories, again, we won't do category 1, that's permanent risk. G says it's gas. EX says it's a hazardous area. And interestingly, fans have been nominated as non-electrical equipment. So that's where the H comes from. In this case, it's a 2C gas and T4 temperature class. So that label tells us everything we need to know. If you select a fan in the new fan selector, you'll be taken on this journey of actually putting together what fan you need before you do the selections. We'll look at dust. Go through the same process again. And we don't do the underground or category 1, but this time you can see it's dust. Again, hazardous area. Again, non-electrical equipment. In this case, 3B dust group, which is means that covers 3A but not 3C. The maximum surface temperature for that is 120 degrees C. That's a very, very common base ground for dust motors. So I think it's worth understanding what we do in terms of the way the fans are specified and built. We decided as a company to go the route of using the ATEX specific standard for fans in potentially explosive areas. This is the second edition, and it lines up with the second revision of the ATEX codes and standards. What happened is that when the standard was put together, a group of experts, only a few fan people, but there were risk people, there were chemists and experts in the field, put together the standard based upon the risk that they saw and the codes that needed to apply. So that means that the range that this covers is from -20 to plus 60 degrees C. We can go higher if the components are certified higher. Ambient pressure range 0.8 to 1.1 bar, less than 21% oxygen, and basically pressures below 30 kilopascals. That needs special design after that. It's not the only standard within the world. If we look at the US markets, there are NEMA codes and classifications, of which the basis is very, very similar to the ATEX code, but our fans cannot say they've been fully compliant with them. We comply with the ATEX code. And the other one in more recent times has entered in is ICEX, but they don't have a tidy fan standard. What they do, they've got electrical and mechanical standards. And so you have to become your own expert in terms of dealing with that. So we, along with the majority of the industry, will go along with the dedicated ATEX code. What does it mean for us as a supplier? We need to supply you with a product that's compliant. The ATEX 153 risk assessment tells us the zones that we need to apply. We have to build a fan fully compliant with components that match the gas or dust class that we're supplying. So what happens is that we've constructed a technical file that is lodged with a notified body, and that demonstrates how we manufacture the product in accordance with the fan code. So that says what we do. We then monitor that in terms of our ISO 9001 processes. So there are processes within the factory that are part of that technical notification. And CIRA are the body who hold our technical details. Okay. If we make any product, a big change to a product, we have to lodge it with CIRA, and that's kept for 10 years. The purpose of that is if there was ever an incident and the whole thing was looked at, they would look at the product, make sure that we'd made it in accordance with what we said. So we're using the best practice all of the time. But most important thing is the product must be supplied in accordance with the details supplied on the ATEX form. So what we're doing, just a reminder, product 2 products, we don't do anything for zone 0. We don't offer products for 1G or 1D, just to keep reiterating that. 2C motors are a higher specification than the standard motor. So again, they would become something we would quote from here, as would 3C, because that require IP65. The IP rating, the first digit is dust, the second digit is moisture. So that's the standard is IP55, so it's an increased standard of dust ingress. And the product that we have is T4. So, but anything that requires T5 or T6, which is a lower surface temperature, requires a special addition. Enough talking, let's actually have a look at a product. So it's, there's no such thing as a typical ATEX fan. This is an ATEX product. And the ATEX motor, you notice, has a pretty significant terminal box on it. In fact, the later ones are even larger than this. And that's because they have to be explosion proof. The fan has effectively what is another little duct that runs inside the duct, fixed to the duct wall. that's a spark minimizing feature, so that if there was ever contact between the rotating impeller and the outside, the dust, the generation of spark is absolutely minimized. The fact that you can see the tip gap means that it's a much bigger than standard tip gap. We have an ATEX terminal box. In fact, these are probably more compact than the standard one, but they are specifically manufactured for ATEX use and certified. So all of these things would have a separate certification, particularly the glands, where it passes through the duct and the conduit into the terminal box there. So the basics of the fan are, of course, is a standard fan, but with modifications, but it has to have more care. There has to be extra checks. The other thing that doesn't show here is that on the impeller, there's a secondary fixing device, which means the impeller cannot shake loose. Because obviously anything that that risks having a contact, we want to avoid. For dust, for the higher group of dusting, you would also put vibration sensors on the fans, because obviously one of the risks with dust is that there's a build-up of dust, goes out of balance, maybe causes some sort of failure, bearing failure, the impeller drops, hits the contact. So yeah, that would be covered by that. But the big principal things that affect what happens with the fan is the increase in tip gap, because that reduces the performance, it reduces the pressure development. So for the same duty, you've got a higher power, and in some cases, a larger fan. The same thing goes if you had a centrifugal fan between the inlet eye of the fan and the impeller. That all of the clearances have to increase. So there's a pressure change on that. And for the axial flow fan, you've got the influence of this huge terminal box in the airway, which anything in the airway is bad news in terms of losses and noise. If we look at one of the other things that's happened in recent times are the actual changes in terms of the motor designation. People understood, so the EXN motors are now an EXNA, EXEC marking. I'm not quite sure really quite why these were changed, but they did. So that is for our Zone 2 product, we could fit that. But for the standard product, we would use the EXD machine, which is now EXDB. You can see that that is labelled as a T4 motor. Okay, that's 2B gases as standard. So just really the EXD is a higher classification in terms of the risk of explosion and containing any explosions that might go on. The EXN is much more like a standard piece of equipment, but so it's just done so it can't ignite the explosive atmosphere. Right. So the important thing for us, we need to know is that, again, 1453 mandates that risk environment. So that will be zoned. So then that legal requirement that we have to have our form before we can manufacture any product cannot be completed by flak goods. I know that frustrates, but it's a fact of life. Someone has to take responsibility for analysing. So then we will supply the ATEX equipment to go into the zones. So our product has been designed in accordance with the fan code. So designed for Zone 1, Zone 2, Zone 2.2 is standard. So that's the dust one. If we want to have Zone 1.2, we need to understand from the site if there's any preference in terms of vibration monitoring equipment, because it's no good for us to decide on one and then that doesn't integrate with the systems at site. Okay, so again, our ATEX fan will give less performance than if you looked at the equivalent fan and it was non-ATEX. Okay, so the new software allows that fan to be selected when you're looking at your completed form. So that will tell you whether you can actually select the fan that you require from the range. So really what this does is to show what the standard product can do. So anything in green is covered by the standard product here. Okay, so we can do zone 2.2 dust as standard. Zone 2.1 means that we need to understand the vibration situation. But for the gases, if it's T5 or T6, that will need to be specially quoted. So I think it's just worth remembering that is increased time and increased cost to do that. Right, I think that with that, I've covered what I need to cover.